Hey, happy Monday everyone. Exercise 2.3, investigating parallelograms using congruence. This is one of the exercises that you will find you get through pretty quickly. There's a few little things, symbols and vocabulary to look about. Parallel, that's the symbol for it there. Perpendicular, we write like that. I would probably usually write it with the little right angle drawn in, but that's just me. To bisect means to cut in half. What is a parallelogram? A parallelogram is any quadrilateral with opposite sides parallel. What properties does that include? If both opposite sides are parallel, they will be equal, opposite angles are equal, and the diagonals bisect each other. And if any of those tests on the right are true, then you are going to have a parallelogram. Special sorts of parallelograms. A rhombus, it's a parallelogram with all sides of the same length. A rectangle, a parallelogram with all angles the same size, all angles 90, and a square, it's a parallelogram that is both a rectangle and a rhombus. This sort of sums up underneath here exactly how it works. Rhombi, all sides are equal. You've got rhombi and squares. All angles equal, rectangles and squares. So you can see the one that is in the intersection of the two areas, squares. So all squares are special types of rectangles, and all squares are special types of rhombi. And all rhombi, squares and rectangles are special types of parallelograms. What sort of questions will you get? Pretty straightforward, easy ones. I thought I'd do one with you here just to make sure you know exactly what's required. Complete these steps to prove that if one pair of opposite sides is equal and parallel in a quadrilateral, then it is a parallelogram. Okay, so first I need to prove that triangle ABC is congruent to triangle CDA. Remember from the last video that the labeling is important there. But let's just go with what we would know. Well, we know that this angle here, let's call it alpha. If I follow my Z rule, some of you are going to call it, if you imagine that's a Z that's tipped over on its side, I would call it the alternate angle rule. You will see that those two angles must be equal. So how would I start by doing that? I would say angle DAC is congruent to angle BCA. That pen looks terrible because it's the thin. It's supposed to be the thick one, but it looks thin. I'll try black. Alright, so I've got that. What do I know? Side AC is obviously congruent to side CA. Whether I'm going one way or the other, they're exactly the same size in length. So that's pretty easy. And what do I need? I've got angle side, I'd need another angle. Oh, lo and behold, this angle down the bottom here, this angle CAB, is congruent to angle, now I went from C to A, so it will be ACD. No extra C on the end of that, just ACD. Therefore, triangle ABC is congruent to triangle CDA, and the reasoning that you can use is, whoa, angle, side angle. I left out the little A there. Let's sneak it in. Alright, hence prove that AB is parallel to DC. Well, proving that those triangles are equal, oh, I didn't label in that dot there. Given that those angles are equal, then these sides must also be parallel, as we have two pairs of alternate angles there. We have alternate angle there and there. That's a pair of alternate angles, which would make those other two parallel. It's that easy. So then you could write, therefore, for part B, we've already got angle CAB is congruent to angle ACD. And we can even write that they are alternate. If they're alternate angles, that implies that DC is congruent to BA. There you have it.